are basically a very, very important part of our curriculum. So to begin with, we'll go through some definitions. So the formula that we're going to use throughout the chapter is A equals P multiplied by 1 plus R to the power of N. So let's first explain what those letters actually mean. A is called the future value. Okay, so this is the future value, the value of the fund at some point in the future. P is called the present value. That is the value of the money today. Okay, so 100 euro today has a value of 100 euro today, etc. So A is the amount in the future, P is the value at the present. The interest rate R, or more specifically the decimalized interest rate R, is the interest rate divided by 100. So let's imagine that the interest rate at the moment is 2.5%. That would mean that the decimalized interest rate would be 2.5 divided by 100. So that would mean that R equals 0.025. Okay, so if the interest rate was 2.5%, the decimalized interest rate R would be the interest rate 2.5 divided by 100. Now, N is the number of terms. Now, be careful here. The number of terms is usually months. If you're paying a mortgage, if you're paying a car loan, if you're a regular saver into a pension fund, generally your payments are made on a monthly basis. So generally speaking, N is a number of months. But just be very, very careful. Sometimes it's not. Sometimes N is the amount of time in years, if it's a quite straightforward question. And one thing that I feel the examiner may look at is measuring N in terms of quarters. The banks trade with each other using what's known as the quarterly interest rate. Okay, a quarter of a year is 3 months. So in every year, obviously, there will be 4 quarters. And over a 10-year period, that would obviously be 40 quarters. Now, they have yet to ask that in the actual exam, but just be aware of the fact that they could. So what we're going to do is we're going to look at some very, very simple examples that we can use to kind of develop this formula, A equals P into 1 plus R to the power of N. Now, in our first example, we will imagine that somebody called Tom lodges a one-off lodgement of €2,500 into a savings account at an AER, that's an annual equivalent rate, of 2.1%. What is the value of the fund after a period of 6 years? Now, first of all, let's collect our variables. Well, the present value, P. Today, as Tom makes his lodgement, the present value is €2,500. Okay? The interest rate, or the decimalized interest rate, is going to be the interest rate divided by 100, which is 2.1 divided by 100, which is 0.021. Move the decimal place 2 places to the left. Then N is time, and in this case, time has been measured in years. So N is very simply 6 years. Now, the formula that we use is A equals P multiplied by 1 plus R to the power of N, that formula from the previous screen. So that's €2,500, the present value. That's the value of the money on the day that Tom made the lodgement, multiplied by 1 plus R. Now, R is 0.021, so 1 plus R is 1.021. And we must put that to the power of 6, to the power of the amount of time which has passed. Now, when we work that out on our calculator, we obtain a value of €2,832.01. Okay? Now, again, just to be clear, the present value P, that is the value on the day that Tom made the lodgement, €2,500. The interest rate is 2.1%, so the decimalized interest rate is going to be 2.1 divided by 100, which is 0.021. And that means that 1 plus R is going to be 1.021. So that was a very, very straightforward calculation. As you can see, the next question we're going to look at, it concerns inflation. Now, inflation is the way the prices of goods or services increase over a period of time. Now, Central banks tend to aim to keep the rate of inflation below approximately 2%, and that varies from time to time. But what we're going to try to do in this question is we're going to analyse the way the price of an ordinary packet of crisps has changed since 1980. So in 1980, that was at the beginning. Now remember, at the beginning of a fund, that's the present value. So the present value of a packet of crisps was 10 cent in 1980. The future value is €1, which is 100 cent, and that is in 2020. The amount of time that has passed, we're measuring in this case in years. They want to know the annualized rate of inflation. So that's going to be 2020 minus 1980, which is 40 years. Okay? So the amount of time is 40 years. The future value is 100 cent. The future is now. The present value back in 1980 was 10 cent. Okay? So A equals P multiplied by 1 plus R to the power of N. And that means that 100 equals the value in 1980, 10 cent, multiplied by 1 plus R. We have no idea what R is. That's actually the question, to find out what R is, to the power of the amount of time which has passed, which is 40 years. Now, if you move something across an equal sign, you replace it with its opposite. The opposite of multiplying by 10, this 10 here, is to divide by 10. So 100 divided by 10 equals 1 plus R to the power of 40. Now that means that 1 plus R to the power of 40 is equal to 100 over 10, which is 10. Now, if you move a power across an equal sign, you turn that power upside down. So that means that 1 plus R is equal to 10 to the power of, if we flip 40 upside down, that becomes clearly 1 over 40. So that's 10 to the power of 1 over 40. Again, we refer to our calculator. So we type in 10 and then the y to the power of x button and then 1 over 40. And that's going to give us a value of 1.05925 and a whole lot of other decimals. But that's enough decimals for now. So if 1 plus R is equal to 1.05925, that means that R, to obtain R, we simply bring the 1 across, it becomes minus 1. And 1.05925 minus 1 is 0.05925. Now remember, we're not finished. That R is the decimalized interest rate, which means that R is the interest rate divided by 100. So that means that if we want to calculate the interest rate, we got to multiply this by 100. And multiplying by 100 means moving the decimal 2 places to the right. So that's going to be 5.925% per annum. So that means that if we were to use the CRISP index as a way of analysing inflation over the last 40 years, we would be looking at an average rate of inflation of 5.925% per annum. Now, what's in particular importance in this question is what happened between this line here and this line here. That when you bring a power across an equal sign, you turn that power upside down. And it does trick quite a few people when the examiner asks them to find the interest rate. Okay, so just practice this question a little bit, make sure you kind of get it into your mind, get it solid in your mind. Okay, so we've looked at a very simple situation where a person lodges a fixed amount of money for a fixed amount of time, given the interest rate. Now we've looked at a situation where we made a lodgement, we looked at inflation, the change of value in an item over a period of 40 years, and we were asked to calculate the rate of inflation. Now we're going to look at a very, very practical situation where a person lodges a fixed amount of money per month over a given period of time. So let's have a look at this question. So a lady called Susan decides to save a sum. We're going to highlight all of the important parts in the question. They decide to save an amount of €400 per month over a period of 5 years in a savings account at an agreed AER, annual equivalent rate, of 2.5% per annum. Okay, 2.5% per year. Remember, AER means annualized equivalent rate, okay, of 2.5%. It's really important in questions like this where there are multiple lodgements that you pay close attention to when the first lodgement was made and when the last lodgement was made. So she makes the first of these lodgement today. So her first lodgement is today. That is on the day she opens the account. And the last lodgement, right here, is 1 month before the 5th anniversary of opening the account. So the first thing you do is you highlight or you underline the important parts of the question. Now, what we need to do here is we need to go through each of these payments one at a time, okay, and add them together as a geometric series. Now, remember that the formula in the background is A equals P multiplied by 1 plus R to the power of N, okay? Now, the only issue that we have is that we're quoted an annual interest rate, but Susan is making these lodgements on a monthly basis. So that's our first target, to find out what 1 plus R is. So 1 plus R equals, now the interest rate is 2.5% per annum. So if we divide that by 100 to get our decimalised rate, that's 0.025. And then if we add 1, we have 1.025. Now that is annualized. We need to find out the monthly, so we need to put this to the power of 1 over 12. Okay? If it was quarterly, we would look at to the power of a quarter, but this is monthly, so it's the power of 1/12. Now that gives us a value of 1.002059836. Okay, so 1.002059836. Now, a very simple way of thinking about financial maths is this. If you feel that the value of a fund should be increasing, you multiply by 1 plus R to the power of the amount of time. So like a savings account or an investment account, you would like that fund to increase, so you would multiply. For a loan account or for a mortgage account, you would like the amount to be decreasing over time. So for a loan or a mortgage, you would divide. So for savings account, you multiply. For a loan account, you divide, or a mortgage. So let's see what happens. The value of the fund equals, now her first lodgement she makes today, and that is a lodgement of €400. Now she's going to do this for a period of 5 years. Okay, so this first payment that she makes is going to be sitting in the bank for the full 5 years. So that's going to be 400 multiplied by 1 plus R, 1.002059836, to the power of the amount of time that it's going to be sitting in the account. Now this will be in the account for 5 years, and 5 years is 60 months. Everything now must be counted in months. So that's the first lodgement that she made. The second lodgement that she made was a month later. So that's 400 multiplied by 1.002059836. But this is to the power of 59. This one is to the power of 59 because it's got 1 month less to earn interest. Remember, the first lodgement was made today. This one is made in a month's time. So it's going to be 1 month short of 5 years, which is 59 months. Now, this is going to keep going and going and going. So plus ... just to fill in the blanks in between. Then if we look at Susan's last lodgement, it's 400 multiplied by 1.002059836 to the power of the amount of time that her last lodgement is going to be in the account. Now this is where I need to read very carefully the second thing that I underlined. Her last lodgement is made 1 month before the 5th anniversary of opening the account. So what that means is that this lodgement is only going to have 1 month to earn interest. So it's to the power of 1. Okay? Now, the next line that I'm going to take is I'm just trying to simplify this down as a geometric series and then find out the total value of the fund at the end. But the way I'm going to do this is that I'm initially just going to take out that common €400. Okay, it appears everywhere, so let's take it outside a set of curly brackets. The second thing I notice is that the powers are reducing as we go across. Now, I would be much, much happier if those powers were increasing as we go across. So I take out the 400, but I also reverse the order of the powers. So this becomes 1.00205, 9836 to the power of 1. The last one becomes the first one, plus 1.00205, 9836 squared. Remember, you're counting backwards. So if the last one was to the power of 1, the one before that would have been to the power of 2. And then this keeps going plus ... all the way to the end. So we have 1.00205, 9836, my apologies, 9836, and that's to the power of 60. Because remember, the first one is now the last one. Okay? Now, if we look inside here, inside in the curly brackets, we can see very, very clearly that this is geometric series. Okay, it's a geometric series. So we'll just write that down. This is a geometric series inside the curly brackets. So we're leaving out the 400. The first term A is 1.00205, 36. And the common ratio, the number that we're multiplying by every time, is the same number, 1.002059836. Now, the symbols that I'm going to use through this series of videos on financial maths is that little r is always the decimalized interest rate, and capital R is always the common ratio of a geometric series. Okay, so little r is the decimalized interest rate, and capital R, as I said, is the common ratio of a geometric series. Now, when I'm doing these questions, I always pause at this moment and I have a think about R. For something like a savings account or an investment, where you would expect that the value of the fund will be increasing, the common ratio should be larger than 1. Okay, if it was smaller than 1, it means you're losing money, the fund is going down. So the common ratio needs to be larger than 1. So I look at this, I take a quick glance at it and I say, well, that's fantastic. I got something slightly above 1. So this is actually going to grow. So it looks like I'm probably right. Okay. Now, the next thing we think about is the sum of the first n terms of a geometric series. We have Sn equals A into r to the power of n minus 1 divided by r minus 1. Because r is bigger than 1, I have swapped around the top line in the formula in the log tables. Okay, in the log tables, it's A into 1 minus r to the power of n over 1 minus r. But I changed the sign on the top and the bottom because, to be honest with you, I just don't want to be dealing with minus numbers. Okay, so this avoids negatives. So I will always use this one if r is bigger than 1, and the opposite to it if r is smaller than 1. Okay, so we tidy this up. This is going to be 400 multiplied by the sum of, now if you look at this very carefully, you'll notice that we start counting at 1, then 2, and then we stop counting at 60. So if we count from 1 to 60, that clearly means there are 60 terms in our sequence or in our series. So that means that this is S60, the sum of 60 terms in my series. Now, at this stage, we substitute the values that we have over here into this formula to calculate the value of the fund. So this is 400 multiplied by, well, first of all, we have A, which is 1.002059836. Then we have r to the power of n minus 1. Now, r is also 1.002059836. And we put that to the power of 60 because in total, this woman, Susan, she makes 60 lodgements into her savings account. Minus 1. And then on the bottom, we put in R minus 1. And again, R is 1.002059836. And then we subtract 1 from that. Okay? Now, you get your calculator, you put all of those numbers in, and the grand total after this period of saving for Susan is €25,570.75. Now, every savings account you handle the exact same way. You express it like we did up here as a sum of all of the payments multiplied by the interest over that time. So A equals P multiplied by 1 plus R to the power of N for each individual payment. Then you always take out what's common, which is going to be the amount that's lodged every month. You always reorder the powers so that the lowest power comes first and the highest power comes last. You always describe it as a geometric series, and you find out what A is, you find out what capital R is. Always pause to double check that capital R is bigger than 1. Okay, it needs to be bigger than 1 for a savings account or for an investment account. It needs to be smaller than 1 for a loan or for a mortgage. Okay, so I really, really hope that you enjoyed this video, and I look forward to seeing you in later videos in relation to loans and pension funds. So thank you very much for listening. Bye-bye now.